So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic projectile motion. So in short, state at the end of this video. Let's go ahead and start with the first question here. It says, a coin is pushed from the edge of a laboratory bench with a horizontal velocity of 15 meters per second. If the height of the bench from the floor is 1.5 meters, calculate the distance from the foot of the bench of the point of impact with the floor. Alright, so guys, here if we want to calculate the distance here from the foot of the bench to the point of impact on the floor, we have to calculate this as a range. So assuming we are using this as the range x is equal to ut, we have to find the time first of all before we can solve using ut, guys. So the time here will be given as root 2h over g. So the height of the bench, that's the maximum height here, is 1.5 meters, and 1.5 times 2 is 3. So 3 over 10 is actually 0.3. So in that case, t is equal to 0.3 meters. So now we've gotten t, we can now calculate for ut. So where the initial velocity u is 15 meters per second. So if we multiply 15 meters per second by square root of 0.3, we'll have 8.22 meters. And that's option B here, guys. So let's go ahead and consider the next question. So the next question we have here is question number 2. It says, at a birthday party, the celebrant pops a corked fruit wine. If the cork shoots out of the bottle at an angle of 40 degrees to the horizontal and travels a horizontal distance of 4.5 meters in 1.25 seconds, calculate the initial speed of the cork. So guys, using the range r is equal to u cos theta t. So we are going to have that u is equal to the range r all over cos theta times the time. So cos theta t here, cos theta is actually cos 4t. So in this case, we will have the range r here is 4.5 meters, and this will be divided by the cos 40 times 1.25. So guys, that will give us in total 4.7 meters per second. So let's go ahead and consider the next question, guys. So the next question we have here is question number 3. It says, the ratio of maximum range to maximum height of a projectile is 4. Determine the angle of projection. Alright, so guys, for us to determine the angle of projection here, we're going to have that the ratio of maximum range to maximum height here is actually the maximum range r over the maximum height h, and that's equal to 4. So in this case, maximum range is u squared sine 2 theta over g, whereas the maximum height is u squared sine squared theta over 2g. So in that case, we have u squared sine 2 theta over g divided by u squared sine squared theta over 2g, and this is equal to 4. So in this case, if we change the sign of division to multiplication, we are going to have u squared sine 2 theta over g times 2g over u squared sine squared theta, and this is equal to 4. So guys, we can go ahead and cancel out some factors. So we cancel out u squared, and then we cancel out g. So here we're going to have 2 sine 2 theta over sine squared theta is equal to 4. So guys, at this point, we can actually have that 2 sine theta cos theta is equal to sine 2 theta. So since we know that sine 2 theta can be replaced by 2 sine theta cos theta, then in that case, these 2 times 2 sine theta cos theta all over sine squared theta is equal to 4. So guys, if we rearrange this, we are going to have that 4 sine theta cos theta is equal to 4 sine squared theta. So we can cancel out 4 in the two parts of the equation, and then we have that sine theta cos theta is equal to sine squared theta. Then we can still cancel out sine theta between the two, and then we have that cos theta is equal to sine theta. So if cos theta is equal to sine theta, then we can say that sine theta over cos theta is equal to 1. So if sine theta over cos theta is equal to 1, then let's recall that sine theta over cos theta is equal to tan theta. So sine theta over cos theta is equal to tan theta. In that case, tan theta is equal to 1, and then theta will now be tan inverse of 1. So guys, tan inverse of 1 is 45. In that case, theta is 45 degrees. And that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 4. It says, the time of flight for a projectile motion is given by the expression A, u squared sine theta over 2g, B, u sine theta over g, C, u sine 2 theta over g, D, 2u sine theta over g. So guys, the answer to this question here is option D, 2u sine theta over g. Actually, the time of flight here is 2 times the time taken for the maximum height. So the time taken for the maximum height is u sine theta over g, and then the total time of flight will now be 2 times that time, and that's 2u sine theta over g. So option D is the answer to this question. Let's go ahead and consider the next question, guys. So the next question here is question number 5. It says, a body is projected with an initial velocity u at an angle theta to the horizontal. The time taken by it to reach the maximum height is given by the expression A, u sine theta over g. So guys, the answer to this question here is option A here. We don't need to check further for the rest options. The answer here is u sine theta over g. So that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 6. It says, a body is projected with an initial velocity u at an angle theta to the horizontal. If R max is the maximum range of the projectile, what does the relation represent u squared over R max respectively? Alright, so guys, the option A here says the horizontal distance covered. Option B is the acceleration due to gravity. Option C is the vertical distance covered. Then option D is acceleration of the body due to gravity. So guys, for this question now particularly, we have to note that if angle theta is 45 degrees, then the equation u sine 2 theta over g will actually be u squared sine 90 over g, since 2 theta, which is 2 times 45, is 90. So that will be u squared sine 90 over g, and sine 90 is 1, so in that case that will be u squared over g. So it means that the maximum range will be u squared over g. So if maximum range is u squared over g, then g is equal to u squared over the maximum range. So which is this expression here. So the acceleration due to gravity is actually u squared over the maximum range. So that's it for this question. Option B is the answer to this question. Option D here is the answer to this question, and that's the acceleration of the body due to gravity. So let's go ahead and consider the next question, guys. So the next question we have here is question number 7. It says, at what angle to the horizontal must the nozzle of a machine gun be kept when firing to obtain a maximum horizontal range for the bullets? So guys, here, obviously, the answer is going to be 45 degrees like we mentioned. And in that case, the maximum range, R maximum, has the equation u squared over g. So it has to be at angle 45 degrees, and that's option C. Let's go ahead and consider the next question, guys. So the next question here, question number 8 says, a body is projected horizontally from the top of a cliff 45 meters above the ground. If the body lands at a distance 30 meters from the foot of the cliff, calculate the speed of the projection. So guys, here, in order for us to calculate the speed of the projection, we already have the height here, height of the cliff 45 meters, and the distance from the cliff, from the bottom of the cliff, is 30 meters, and we have acceleration due to gravity as 10 meters per second. So we're going to calculate for the range here using range R is equal to ut, but then we don't have the t, so we are going to calculate for the t here using the equation t is equal to root 2h over g, but then the h, which is the height of the cliff, is 45 meters. Actually, we are going to multiply the h by 2, giving us 90, and then when we divide it by the g, that will give us 9. So square root of 9 is actually 3. So in that case, t is 3. So if t is 3, then ut is going to be initial velocity times time. So here we have the maximum range already given to us, so we are just going to find the initial velocity. So that's the speed of the projection. So in that case, since range is equal to ut, then u will be range over t. So the range given to us here is 30 meters, and then the t is 3. So 30 over 3 is 10. So that's option D here. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 9. It says, an object is projected with a velocity of 100 meters per second at an angle of 60 degrees to the vertical. Calculate the time taken by the object to reach the highest point. Take g as 10 meters per second. So guys, let's note that here v naught sine theta is equal to gt, since v naught sine theta minus gt is equal to 0. So here, if v naught sine theta is equal to gt, that means t is equal to v naught sine theta over g. So in that case, v naught is the velocity of projection, so which is 100 meters per second, then sine theta is 60 sine 60, so 100 sine 60 over 10, that will give us 8.7 seconds, and that's option C here, guys. So that's it for this question. Let's go ahead and consider the next and last question, guys. So the last question we have here is question number 10. It says, the angle at which a projectile must be fired to cover maximum range is A, 90 degree, B, 30 degree, C, 60 degree, D 45 degree. So guys, take note of this. The angle which a projectile must be fired to cover a maximum range is 45 degree. That's because 45 degree will give you, when you have u squared sine 2 theta over g, you will have, if you have 45 degree, then 2 theta is 90 degree and sine 90 is 1. So the equation becomes the equation of the maximum range, which is u squared over g. So take note of this, guys, and this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video,